G'day YouTube, Dr. Freed here, bringing you a presentation on Bayes' theorem and the resurrection of Jesus. So a while back I watched a debate between William Lane Craig and Bart Ehrman on whether historians could be certain of the resurrection of Jesus. Craig argued the affirmative and Ehrman the negative. A key feature of the debate was Craig accusing Ehrman of being simplistic in his calculations of probabilities. Craig believed this led Ehrman to commit an egregious error. Well, I'll explain just what this supposed error was later on, but let's just say that the purpose of this video is to show that it was Craig in error, not Ehrman. So, in the lively spirit of name-calling initiated by Craig, I present to you Craig's calamitous cock-up. Now let's just quickly run through some basics on probability. P of R stands for the probability that some proposition R is true. P of R given E stands for the probability that R is true, assuming E is true. So the probability of some unknown person being male is about 50%. Now we're not talking about a scientific probability here, but a historical probability. A scientist might be able to tell you that there's exactly a 50% chance that a given person will be born male, but all a historian could do is count the number of males that have ever lived and divide this by the number of people who have ever lived, and the result would be around 0.5. If the person's name was known to be Bob, then the probability would be closer to 1. It might not be exactly 1 because there might have been some females called Bob. But if the evidence went against the proposition, it would lower the probability accordingly. Now what has this got to do with Jesus? Well, this is a question we're interested in here. What are the odds that Jesus rose from the dead? Do we just divide the number of actual resurrections by the number of opportunities someone has had to rise from the dead? Well, this would be the intrinsic probability of some person rising from the dead in the absence of any evidence. Is it something more like this? Well, to answer this properly, let's set the question up formally. Let's let R be the proposition that Jesus rose from the dead, and let's let E stand for the evidence in favour of Jesus' resurrection. So this includes the biblical claims of an empty tomb, post-mortem appearances, and so on. And the key question is, what is the probability that Jesus rose from the dead given this evidence? Or more specifically, how does a historian figure out this probability? Now I don't have much time to talk about the nature of the evidence E or the intricacy of the statement of proposition R, but I would like to say a few things. Now first, Craig says these things are not just claims but facts, accepted by the majority of New Testament scholars. Well, of course the majority of New Testament scholars accept them, because the majority of these scholars are Christians. They also believe in the resurrection itself, and they believed long before they became scholars. Should we just believe them and accept their word for the resurrection? Of course not. And we should be equally reserved about what is being presented here as evidence. The next thing to note is that our sources of these claims are authors writing approximately half a century after the events supposedly took place, and they're narrating stories that have been spreading over these decades. The pieces of evidence Craig relies on are just details in the stories, and they're the sort of details that should be present in any serious resurrection claim. Who would believe you if you claimed, or genuinely believed, that a person had risen from the dead if you thought they were still in their burial place, or if you didn't think anyone had actually seen them after the resurrection? No, these are the bare essentials of an even halfway believable resurrection claim. So the evidence is that people claimed Jesus had risen from the dead. Now this is not just any old claim, like I could make about my grandma, say. It's a serious claim, but it's a claim nonetheless, and there have been several serious resurrection claims over the centuries. It's also worth noting here that Craig wants to change R to the proposition that Jesus was supernaturally raised from the dead. He believes that the arguments of natural theology prove that God exists, so it's safe to assume that he does. Now what are the arguments that Craig generally presents in his debates on the existence of God? The cosmological, fine-tuning and moral arguments all leave us with at best an abstract entity who calculated the constants of the universe, decided what would be right and wrong, and then started the whole show. Even if we grant the conclusions of these arguments, we have no reason to assume that such a God is the God of the Bible, or even a being with a personal interest in intervening in the world in any way, let alone raising someone from the dead. The arguments that Craig uses to introduce Yahweh into the picture are the historicity of the resurrection of Jesus and the witness of the Holy Spirit. Well, clearly we can't use the former in the current context, and Craig says in most debates that the latter is not really an argument at all. The conclusion is that although it's quite possible that the God of the Bible exists, and that Jesus rose from the dead supernaturally, a historian does not have any reason to assume the existence of a God who is motivated to intervene in the world to raise someone from the dead. I'm absolutely not saying we should rule out the supernatural. We're just not allowed to assume the supernatural. In particular, we aren't allowed to include it in either the proposition R or the evidence E. And now we get to what Craig calls Ehrman's egregious error. Craig believes Ehrman in his confusion has forgotten to consider the evidence, leading to him mixing up the real probability of the resurrection with the intrinsic probability. Craig then goes on to explain that if Ehrman had only taken Bayes' theorem into account, he would have arrived at a much higher probability. But what Craig thought of as a clever calculation turns out to be a calamitous cock-up, as I'll show shortly. I'll then demonstrate that Bayes' theorem really shows that the probability of the resurrection, taking into account the evidence, is equal to the number of true resurrection claims over the total number of resurrection claims. Now at this point I'll jump the gun. Those who disagree with me can call this Freud's fabulous failure if they like, but I'd prefer to think of it as a fabulous formula, and one backed up by solid mathematics rather than an apologetic sleight of hand. Incidentally, this is what I think Ehrman probably had in mind, rather than the confusion Craig attributes to him. And if this is the case, I think it deserves the title of Ehrman's exemplary elucidation. So Craig wants to use Bayes' theorem, and here it is. It states that the probability of a proposition R, assuming the evidence E, is given by this fraction. Now Craig actually uses the more complicated version of the theorem, in which the denominator of the fraction is expanded like this. The funny symbol appearing towards the end of this formula is the not symbol. Now Craig's version of the formula has B's included in the evidence part of every probability involved, but this is just a matter of taste and doesn't affect the statement of the theorem. We can just agree that every probability value takes into account all the background knowledge we otherwise have. Of course, if you're interested in learning more about the theorem, including who Bayes and Laplace are, feel free to go to the Wikipedia page. Now the first key observation is that the numerator of the fraction is reproduced in the denominator. So the fraction is of the form x over x plus y, where x and y are these more complicated expressions. Yeah, before moving on, let's point out the obvious. If p of r equals 0, then the whole fraction is equal to 0. I'm sure this is not what Craig wants, but let's just move on. Alright, now we can start to see just how Craig uses Bayes' theorem in order to make it look like it says something it really doesn't. Craig notes correctly that the probability is of this form, x over x plus y. He then says, as y tends towards 0, the value of this ratio tends towards 1, which in probability theory means absolute certainty. Or in symbols, as y approaches 0, the probability approaches x over x plus 0, and x over x is just equal to 1. Now why does Craig think we can let y approach 0? Because y is small. But here I think Craig is confused. The problem is that being small is not the same as tending towards 0. Now this might seem like a minor point to a non-mathematician, but in fact this is the key step in Craig's little trick. The point is that even though y is small, so too is x. And if we're allowed to just let x approach 0, then the probability approaches 0 over 0 plus y, which is equal to 0. And as we all know, in probability theory this means absolutely certainly not. So, how can the same method lead to two completely different answers? Simple. It's a bogus method, not solid mathematics. At this point it's worth wondering why Craig used a bogus method to try and prove his case. If he knew his method was bogus, then he's guilty of deliberately deceiving people in order to try and make his audience believe him, and to try and make his opponent look stupid. If he didn't realize his method was bogus, then he made some pretty embarrassing mathematical errors, and all while attempting to mock Ehrman for supposedly making mathematical errors of his own. Neither option does much for Craig's reputation here, and I think it's apt to quote his own words, and repeat that New Testament theologians no longer have any excuse for using such demonstrably fallacious reasoning. The point is that it doesn't matter how small y is. What matters is how small y is compared to x. And here's an example. If we let y be this small number, and x this even smaller number, then the probability ratio turns out to be rather small indeed. No matter how small y is, this probability ratio can be anything at all. And the moral is that without knowing the ratio of x to y, it's not enough to simply know that y, or x, is small. This is easiest to realize when you write the ratio in this form, and you realize that the ratio y over x is the key factor. Now we can move on to the more important question of what Bayes' theorem really says. To do this, we'll need to introduce a number of pronumerals. So let's let n stand for the number of people who have died. Let's let a stand for the number of such people who have risen from the dead. It should be said that here we're talking about really died and really risen. After all, no one's claiming that Jesus passed out for a split second on an operating table. Now most people would probably believe that a equals 0, but I won't be assuming this, so let's just move on. Let's further define b to be the number of resurrection claims that turned out to be true, and c the number that were false. And now let's do some calculations. P of r is the intrinsic probability of the resurrection. Without any evidence, what probability would a historian assign to Jesus' resurrection? Without knowing of any evidence, all they could reliably guess would be the number of actual resurrections over the number of opportunities for someone to have risen from the dead. In other words, a over n. The intrinsic probability of the evidence existing, well, this is the probability that a resurrection claim would have been made. So this is the number of claims, including true and false ones, divided by the number of people who died. And finally, the probability that a resurrection claim would have been made if someone really did rise, well, that's just the number of true claims over the number of true resurrections. And now we can plug these values into Bayes' theorem, and this is what we get. Note that the fraction for p of e has been inverted since we're dividing by that. Okay, now we can cancel the a's and the n's, and we're left with b over b plus c. A nice simple fraction which we'll come back to shortly. So what if we'd tried to use the more complicated version of the theorem? Well, here are the probabilities we worked out before. We won't need p of e, but we'll need a couple more probabilities. P of not r is just the number of people who have not risen from the dead over the number of people who have died, so n minus a over n. And P of e given not r is the probability that a claim would be made for a person who really didn't rise from the dead. So this is the number of false claims over the number of people who have not risen from the dead. And now we can plug these values in. So remember, the complicated version of the theorem says this. Now we plug in the values we've just calculated and get this. Okay, now there's some cancellation happening on top and the bottom of the fraction. And now we times top and bottom by n to arrive at b over b plus c, just like before. Now let's remember what these numbers stand for. B is the number of true resurrection claims, and C is the number of false claims. So B plus C is just the total number of claims. So, what's the conclusion? Well, whichever version of the formula we used, we deduced that the probability of Jesus' resurrection given the evidence is equal to the number of true resurrection claims over the total number of resurrection claims. But this is just the intrinsic probability of any given resurrection claim being true. In other words, Jesus' resurrection is just as likely to be true as any other resurrection claim is. In particular, it's just as likely as the resurrection claims of Julius Caesar, Augustus Caesar, Apollonius of Tyana. And as these names come up, just remember that each of these people had serious resurrection claims made about them. But do you honestly believe they rose from the dead?